This is the first lecture on exponents. Before using exponents, we were adding like terms. And if I was to take and add those x's up, there are 4 x's being added. We call that 4 out in front a coefficient. It describes how many x's were being added. Well, when we look at exponents, we are now trying to multiply. So we're going to show a condensed version of multiplication. So if I write down the 4 x's but change the operator to multiplication, I can condense this and write it x to the power of 4. The 4 is now called the exponent. The x is called the base. That 4 in the superscript position tells me I had 4 x's being multiplied. Now there are some properties that have to go with exponents, and I recommend that you don't memorize these. You can always show your property through this idea of expansion. For example, x times x squared. X times x squared means I have 2 x's in addition to the first one being multiplied. The x squared was now expanded, and if I look, I have 3 x's being multiplied. So condensing that, it's going to be x cubed. Y to the 5th times y to the 3rd. Again, I have y's being multiplied. I have 5 for the first y to the 5th, 3 for the second base y cubed. Notice they're all the same and they're all being multiplied. There's a big multiplication sign here, and there's ones that are between all of those y's. So when I look at this, I actually have 8 y's being multiplied. 8 y's being multiplied. Notice the 8 is in the exponent position because it's multiplication, not in the coefficient position, which means addition. Looking at the next problem, looks like I need to multiply some things together, but they're not right next to each other. So I'm going to use the commutative property to interchange the x squared and the 2. So the 2 is exchange positions with the x squared. And now that I have my terms right next together, due to the commutative property, I can multiply 2 times 3 just as we know how. 2 times 3 is 6. Looking at x squared, which are 2 x's, and x cubed, which are 3 x's being multiplied, I now have a total of 5 x's being multiplied. Now if you look at a pattern for the product rule, what's happening to the exponents? Well, there's a 1 in this position because there's only 1 x there. 1 plus 2 is 3. In this position, 5 plus 3 matches my exponent of 8. And x squared times x cubed, adding the exponents, gives me that exponent of 5. So if we want to make a rule for this, the product rule tells me to add the exponents. Now we can only add exponents when the bases are the same. Power rule. Power rule changes the position of the exponent. So I now have an exponent raised to a second exponent, which would be the 3 in this first problem. So using my expansion and trying not to memorize a rule, I have x squared 3 times. Now it's really become my product rule, which I had before, or again I can expand it. There are the 2 x's, and I need to do that 3 times. So looking at how many x's, I have x to the power of 6. 3x to the 4th written twice. 3x to the 4th times itself 2 times due to the exponent on the outside. Using my commutative property, I can rearrange my 3's and put them next to each other, which also puts my variables next to each other. Multiplying 3 times 3, I get 9. I have 4 x's and an additional 4 x's, and so now I have 8 total power of 8 on the x only, not on the 9. And then the last problem, x to the 3rd power, y to the 4th power, again written twice. Using my commutative property, I'm going to rearrange these two because I can multiply in any order. So I want my x's to be next to each other and my y's to be next to each other. Combining the 3x's twice gives me a power of 6. Combining the 4 y's twice, adding them up, I get 8. Now there's also a rule that we can kind of discover from this expansion. If you look at the first problem here, 2 and 3 to make 6, I multiplied. 4 and 2 were multiplied to get 8. 2 and 4 again were multiplied to get 8 on the y, the base of y. 2 and 3 were multiplied to get 6 on the base of x. So the power rule says that you multiply exponents. Now what happens if I have a fraction raised to a power? Again, through expansion, I look at my numerator and my denominator. I need to write this fraction down twice. Taking note of fractions and multiplication, I'm going to go straight across. A to the 6th power, I had 3 from my first fraction and 3 from my second. B to the 4th, 2 from my first and 2 from the second from the power of 2. Letter E, again I have 2x to the 4th over y, and I have this fraction written twice. Again, to multiply, I like to go straight across. Now instead of writing the commutative property every time, I'm going to kind of sort these mentally. I'm going to take what we call the coefficients, or the numbers out front. 2 times 2 is 4. Now I'm going to look at my x to the 4th times x to the 4th. If I was to expand or write all of those out, I would have 8x's being multiplied. Y times y is y squared. In the last problem, we have 3x cubed over 2y squared written 3 times. So I'm going to go ahead and copy that down 3 times. Again, I'm going to use a commutative property and sort the terms mentally. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Looking at my x's, I have 3 from each fraction, which gives me a total of 9. Looking at my rule, 3 times 3 is 9. 2 times 2 is 4. 4 times 2 is 8. Notice you don't take 3 times 2 here because the 2 is not a power. The 2 is a coefficient. You only multiply the exponents in this rule. Looking at my y's, I have 2, an additional 2, and then a third group of 2, which gives me 2, 4, 6, or y to the 6th power. 3 times 2 is 6.